Hello, my name is Honza Horak and I will show how to build container-based applications using software collections. Software collections give you the power to build, install and use multiple versions of software on the same system without affecting the system-wide installed packages. All that is available on traditional systems, but you will see that it works even better with containers. During this demo, we will create a container-based application using Python 3.4 and MongoDB 2.6 software collections, both run as Docker containers. Let's start with Red Hat Enterprise Linux 7, where only Python 2.7 is available and there are no Node.js packages in the base system. However, since I've installed Node.js 0.10 software collection, as soon as I call SEL enable Node.js 0.10 to set environment variables correctly, the npm program becomes available. Let's do the same with Docker containers. I've pulled a Docker image with the same software collection. You can see that we don't have to call SEL enable now, and Node.js package manager is available in the container anyway. Usage of daemons like Postgres 9.4 database in a container is also very simple. We can run the container usage command to display help. Following the documentation, we create a directory for data and mount the directory using the -v option. When running the container for the first time, the data directory is initialized, and we have Postgres 9.4 running in the container. That's for the basics. Now let's create some application as a combination of Python 3.4 and MongoDB 2.6, the most popular NoSQL database. We create a very simple Python 3 application in the Flask framework and store it as the APP.py file. However, the Flask module is not a part of the RH Python 3.4 software collection, so we create build.sh, a bash script that installs the missing dependencies. Now we can write a Docker file for the application, which uses RH Python 3.4 image as base, runs build.sh script during Docker build, and APP.py as the main command. We build the Docker image and run it as a container. Let's check that the application works in a browser. Since we also want to store data in the application, we will now connect the application with the MongoDB database, running as a separate Docker container. Documentation shows how the MongoDB image is used. We can run the container and pass database, username and password as environment variables during the start. Now we can extend the application to grab some data from MongoDB. Variables available in the container allow to use the credentials the MongoDB container was started with. We also add some example documents into the database. We use -- link to connect the containers. And let's see in the browser if it works. Well, yes, it does. So we have two containers running and linked together now, one with application based on the Python 3.4 container and second with the MongoDB database. Docker images based on the software collections packages are available now for general usage and for the OpenShift. Check Red Hat customer portal or softwarecollections.org website for more information. Thank you for watching.